Good morning, guys. Am I audible to all of you?
Yes, sir.
Okay. So, in our previous session, we have started discussing concurrent collection and we have discussed concurrent dictionary, right? And we have four more concurrent collection classes, which we will cover today. And from tomorrow onwards, we are going to start asynchronous programming, right? And as asynchronous programming is very very important for you as a developer, right? So from tomorrow onward, don't miss any class because asynchronous programming is very important, right? This concurrent collection classes, if you understand the generic collections, right, then these are not that difficult. You can also understand this thing easily, right? So whatever we have available in generic, those are also available in concurrent collections. So today, let's start a discussion with the concurrent queue. If you understand what is the generic queue, right, then concurrent queue is not a different one, right? Not a different one means what? It means the same functionality what you are achieving using the generic queue class, right? You can also achieve the same thing using the concurrent queue class. But the thing is that generic queue is introduced as part of C# 2.0, and this concurrent queue is introduced as part of C# 4.0, right? If the generic queue doing the same thing and the concurrent queue is also doing the same thing, right? Then what is the difference between them, right? That is what you need to understand, right? The difference between the generic queue collection class and the concurrent queue collection class is that the generic queue is not a thread safe, right? The generic queue is not thread safe, while the concurrent queue is thread safe, right? Both are going to access the data in first in, first out manner only, right? Whatever operation the generic queue is performing, that is following the FIFO principle, the concurrent queue is also going to follow the FIFO principle. But the difference is that, right, generic queue will not provide thread safe in multi-threaded environment, but concurrent queue is going to provide you thread safe in multi-threaded environment. Is that clear, guys? Right. So,
Yes.
so basically,
Yes,
if
sir.
yeah, so basically, if you are developing one application for a single threaded, right? If you are developing a single threaded application, then you need to go with the generic queue. If you are developing a multi-threaded application where you want to access the collection by multiple thread, right? Then in that case, you need to go with the concurrent queue. The working principle is going to be same. Both are going to access the element by following the FIFO principle, right? The element which is added to the collection first will be the one to be removed from the collection first, right? This is the point that you need to remember. Any question from anyone? Guys?
No, no questions.
Okay. So basically, this concurrent collection, this concurrent queue class, provided to constructor. Constructor means it's a non-static class. So if you want to consume any member of this class, then first of all you need to create an instance, right? So this is not a queue, this is concurrent queue, right? So basically you can see there are two constructor, one constructor without parameter, another constructor taking one collection, right? Suppose you are having one concurrent queue collection and you want to create a new concurrent collection with those data, right, which is available in the other collection. You can use this overloaded version. And if you want to create a concurrent collection without if you brand a new concurrent collection with, or you can say the empty concurrent collection where you are going to add the element, right? In that case, you need to use this one, which doesn't take any parameter. Let us see how to use. First of all, this concurrent queue of a T belongs to which namespace? System.collections.concurrent namespace, right? One is system.collection, which is basically for non-generic collection classes. One is system.collections.generic namespace, which is basically for generic collection classes. Another one is system.collection.concurrent, which is basically for concurrent collection classes. So this concurrent queue belongs to this concurrent collection classes. So first you need to import this namespace. Then you can create an instance by following this syntax, right? Without taking parameter, I'm going to use this overloaded version. Right here, type means it can be anything. You can provide any built-in data type like integer, character, right, float, double, etc. Even it is also possible you can provide any complex data type like customer, employee, product, right? Anything you can pass. And whichever type you specified, that type of element you can only store inside this concurrent queue collection, right? Then once you create the collection, then how you can add the element, right? So basically the same principle, same method, right? So in our previous generic queue, right? Generic queue, we are having enqueue method. The same enqueue method is also available here, right? And it is also, you can take, see, it is taking T item. What is T here? Now, T means what is the type you specified while creating the collection. Suppose I am specifying the type as integer while creating this collection. That means here T is nothing but integer item. So while you are calling this enqueue method, you have to specify integer values only. Suppose you specify this type as employee, right? Then while then this T is nothing but the employee, right? And while you are calling this enqueue method, you need to pass the employee date. Give me 1 minute, guys. Right? So this is how this enqueue method is going to work. So what is the definition it's saying? The enqueue method is used to add an element at the end of the concurrent queue. Why it is going to add at the end of the concurrent queue? Because it is following the FIFO principle, right? FIFO means the fast in, fast out. So it is going to add the element at the end of the queue. Here the parameter item specifies the object or element to add at the end of the concurrent queue. The value, right, what you are passing to this enqueue method can be null if T is a reference type. If T is not a reference type, then you cannot pass null values, right? For example, I'm creating a queue, right, concurrent queue collection by specifying the type as int. As I specify this type as int, then I can call this enqueue method by passing integer values, right? But while I'm passing the value, if I'm passing other than integer values, then I will get a compile time error, right? So you can see here, I will get compile time error. Why? Because this is not an integer value, right? And one more thing, as this collection class doesn't have any add method which take T as a parameter, right? So you cannot use collection initializer to add elements to this concurrent queue collection class, right? Doesn't have add method. Clear how to create concurrent queue and how to add elements to the concurrent queue collection.
Yes, sir.
Okay. And coming to how to access element, there is only one option, and that is nothing but your for each loop. By using for each loop, you can access the element of this collection, right? You cannot access by using indexes or for loop. Why? Because this concurrent queue collection class doesn't have any integer indexer, right? By using, so as it doesn't have any indexer, right? So you cannot use index to access the element. As you cannot use index to access the element, so you cannot access the element by using for, right? Now let us see one example to understand what we have discussed so far. Right, let me go to the concurrent queue collection class, right? See, there is no indexer, right? As this class doesn't have any indexer, so you cannot use a for each loop, sorry, you cannot use a for loop, or you cannot access the element by using index position, right? I have shown you two constructor. You can see these are the two constructor, one without parameter and another one taking enumerable of T collection, right? And you can see there is only one method called enqueue. By using this method, you can add elements, right? And you can see there is no add method, so you cannot use collection initializer, right? So once you create, and here I'm creating a concurrent queue of type integer, and here you can see I'm calling the enqueue method, right, by passing some integer value. See, as it is a concurrent queue, so there is no issue adding duplicate element. You can add a duplicate element, that is there is no issue. But as you have mentioned this as an integer type, right? So you cannot add null value. Why? Because this is a built-in data type. This is not a reference data type. Or reference data type, you can pass null, but this is not a reference data type, so you cannot pass null. And what is the type you mentioned here while creating the concurrent queue? Integer. So integer means only integer values you can pass, like 10, 20, 30, 40, like this. You cannot pass other than integer. If you try to pass other than integer value like string, boolean, character, float, right, then you will get a compile time error. So these two statements will give you compile time error, right? Then by using the for each loop, you can access all the elements, right? Now, if you try to use, right, collection initializer, right? Suppose I'm trying to add 10, 20. See what it is showing me? It is giving me that concurrent queue does not contain a definition for add, right? It doesn't have any definition which have add method which can add the element to this collection. So this is not possible, right? Now, if you remember, so which element you add first? This is my first element in the collection, right? This is my second element, right? This is my third element, and this is my fourth element, right? So now, if you want to add a new element, the element is going to add at the end of the queue, right? Suppose I'm trying to add element, right? 50 means it is going to add at the end of the queue, right? So in this case, which element is entered first? This element. So this element is going to be removed first or display first, right? The way you are adding the element, the sequence you are adding the element, in the same sequence, you are going to access the element. Now, let me run the application and show you the output. So in this case, the output should be displayed 10, 20, 30, 30, and what is the last element? 50. 10, 20, 30, 30, and 50. Is that clear? Guys?
Yes.
Okay. Okay, how to remove element? So basically, we have already discussed in our previous sessions, right? In queue collection class, we have dequeue method, right? In queue collection class, we have dequeue method, but in this concurrent queue collection class, we do not have the dequeue method. We have try dequeue method. Why try dequeue method? Because we are going to use this collection class, right, in the multi-threaded environment, right? Multi-threaded environment. And why then you might be have one question, sir, why you do not have a try and queue method, right? We are having try dequeue method, but why we do not have any try and queue method? Because duplicate elements are allowed. Suppose one thread adding this element 30 to this collection, another thread can also add this element 30 to this collection. There is no issue in adding because duplicate elements are allowed. This is the reason why we do not have we do not have this enqueue method, right? But why we are having this dequeue method? Why we are having this try dequeue method? For example, there is one element 10, right? Right? If this 10 element is removed, it's removed by thread 1, and thread is also trying to remove the same 10 element, then at that time that element is not available, right? So it will give you some exception, right? In the case of generic queue, right? This scenario might be possible that one thread already removing the element and another thread trying to remove the element. So this is the reason why they are not providing the dequeue method. Rather, they are providing the try dequeue method. So in the case of a try dequeue method, what will happen? That it will try to remove the element from the collection. Try to remove, but there is no guarantee that the element is going to be removed. If the element is available, then the element is going to be removed. If the element is not available, then no worry. It is simply going to return you false that the element is not exist anymore. If it exists, it will remove, it will return that element, right? And if not exist, then it will simply return false that the element is not available, right? Let me show you this with one example, right? Say in this case, I'm adding 4 elements to this concurrent queue. I'm showing all the elements here, right? And to this try dequeue method, right? If you go to the definition, so it is taking one output, one parameter of which type? Output type, and out parameter of which type? T type, right? So what will happen in this case? Now this method will try to remove the element from the collection, right? If it remove the element, then that removed element will be stored inside this result variable and it will return false. If the element is not available in the collection, in that case, it will not store anything on this result variable. Then what this result variable is going to store the default value based on the data type, and it is going to return me false, right? So in this case, right, so try NQ method, right? So in this case, the try NQ method means which element is added first to the collection, right? That element is going to remove. Which element is added to the collection, that element is going to be removed, and that element will be stored inside this result variable, and this method is going to return me. So in this case, this method will return true, and what element is removed from the collection? This element. So in this case, it will return me what? It will be return the true, and in this case, it will store this value. Okay. Let assume, right? Let us assume that our collection having only one element. So that element will be displayed here. Let assume that we are having two elements, right? So in this case, right? In this case, it will print these two elements. So what will be the output in this case? Output is going to be 10 and 20, right? 10 and 20. In this case, the output is going to be 10 and 20. So in this case, it is going to return true and 10. And after removing this item, so now the collection having only this element 20. So it is going to print what? 20, right? Now again, what I'm trying to do is, again, I'm removing the element. Right? Again, I'm removing the element. So in this case, again, another element is there. This 20 will be removed. After removing 20, it will return that element, and that element will be stored inside this result 2 variable. Right? Now, is there any element in the collection? After this statement, now, what is the statement?
Is empty, sir.
The collection is empty, or is there any element?
Empty collection.
Sorry?
Empty collection.
Empty. So if the collection is empty, now so suppose these two operations are done by one thread, right? These two operations are done by one thread, and this is going to be done by another thread, right? For this thread, the collection is empty. And if he tried to remove the element, right? If you are using the queue collection class, then you will get exception. But in this case, you will not get exception. So in this case, what will happen? This try dequeue method will try to remove the the element from the collection, but there is no element. So what will happen? This method will return false. In this case, this method will return false. And what it will store inside this result 3 variable? Can anybody tell me? What is the data type of this variable? Integer.
Integer.
So the default value for integer. If you create a variable and if you want to store default value, then what is the default value for integer? 0. For reference type, it is going to be null. Right? For string or object, or you can say employee, the default value is null. And for, in this case, for boolean, right? For boolean data type, the default value false. For numeric data type, the default value is going to be 0. So in this case, it will print me 0. So this try dequeue method will not give you any kind of exception. It will either return true or false. When it will return true, when the element is available and when it remove that element. When this method is going to return false, when there is no element to remove, and in that case, this method will return false, and it will set the default value for this out variable. Right? Now, let me run the application and show it out. See, first 10, 20, you remove the try dequeue method return true. This is remove the 10. 10 is the first element is removed. Right? After removing 10, again you are using a for each loop. So that for each loop will give you that there is only one element, 20. You call this try dequeue method once more, it is return true and it remove 20. Again, you are calling the try-dequeue method by using a different thread. Then in that case, it is returning false. And what is the result value? It is result value is 0. Clear? How this try-dequeue method is working? Guys? Yes or no?
Yes, sir.
Okay. Now, if you remember, we have discussed how to get the first element from the collection. In our generic queue collection class, we have discussed dequeue and the pick method. What is the dequeue method? Dequeue method means it is going to remove and return the object at the beginning of the collection. And the pick method means it will not remove the element, but it will only return the element. And the same thing also applicable here. Here we are having try dequeue and a try pick. The try dequeue method will try to remove the element from the beginning and will return that element. Try pick method means it will try to return the element from the beginning without removing it, right? What we have discussed so far in queue collection class, this is the extended version. You can consider the same functionality, but in this case, they are just trying. Trying means there is no guarantee that the element will be written. Element will be written if there is element. If no element, then no return, right? So this is my queue. I'm adding few elements. This is my for each loop, right? This is my try dequeue method. So in this case, it will return 10 and it will remove that element, right? So is removed. So it is going to return true. And in this case, so what it will return? It will return 10, right? Because try dequeue means it is returning true and it is storing that removed element in the out variable, right? After removing the 10, I am just looping through the elements. In this case, you will see 20, 30, and 40 because 10 is removed. Now I'm using try pick method, right? Each pick means it will return true if it will pick the element and that element will be stored inside this variable, right? So each pick it is going to return true and that element in this case 20 will be stored inside this result variable. But in this case, this method will not remove that element, right? That element will not be removed from the collection. So when you run this collection, then you will see all the 3 elements, right? So let me run the application. See, 4 elements are there. Once you remove, right, try dequeue method means that element 10 is removed. Count is 3, 3 elements is there. Try pick method is also going to return true and the element is going to be 20, but this 20 element will not be removed from the collection. So you can see still that element in the collection. Clear? Guys?
Yes, sir.
Okay, fine. Right now I'm going to,
one question.
yeah.
This try dequeue method can only remove the value which is added first, no? It can it be removed at any place?
So okay, first you just tell me why I'm using this NQ method. When I'm going to use queue collection.
Yeah, so like first in first out concept.
Yeah, fast and faster. This is the reason why I'm using this collection. If other purpose there, then why I should use this one? If I want to remove the element at any particular location, right? Then queue is not the ideal scenario. You need to use other collection classes which are available.
But suppose if you have the scenario where the operation should work on first in first out basis, but we want to remove some value in the between, then how can we do?
No. That is not possible.
Okay.
So fast in fast out means it will be only used for fast in fast out collection, right? Then see if you are having some operations, what is the meaning of some? Means what? There is no. If you are thinking in that way, that collection is going to work. This is not possible. This is the reason why they are providing you many collection classes, right? If you want FIFO principle, use queue. If you want LIFO principle, use stack. If you want to store data in a key value pair, use dictionary. If you want to remove return any element at any index position, right? You can use a list collection class, right? So this is the reason why, right? And if you want to store the data in a sorted order, you can go for sorted set, sorted list, right? So they are providing different collection class, and each collection class having its own responsibility, right? So don't mix up, right? If we, there should not be any scenario where you will access the element. Initially, you will trying to access the element by following the FIFO principle, right? And in bit after some time, you want that same collection to work like a FIFO, right? This is not possible,
Okay.
right? Either you have to decide which principle you need to follow, right? So if that is the scenario you want, from the beginning, I want to access the element by following the FIFO, right? After some time, I want to remove the element by following the LIFO. You can go with the list collection class, right? In that collection class, you have the option, you have the flexibility to decide from where you want to remove. Initially, you can remove by using the index position. Later, from the beginning, later you can remove the element from the end, right? That is using that list collection. You can do the same thing, right? Because in this case, indexer is not available, right? Indexer is not available means what? You cannot remove element any from any particular index position, right? So here you cannot specify that I'm going to remove the element from this index position or from that index position, right? Because in this class, if you go to this collection class, right, concurrent queue, they have not that functionality, right? These are the methods they are provided, and you can only use these methods, right? Clear, guys?
Yes.
Right. So now I'm going to show you a simple example, right? I can use with complex data type, right? This is the same principle. You can call this NQ method. You can see I'm creating a class called student having 3 elements, right? This is the same example that we have working so far. Creating a collection, calling the NQ method, adding the student object, right? Here I have to add student object. Here I'm creating the student object directly here. If you do not, if you are not interested like this, you can create student std1 equals to this one, right? You can also create the student object like this, and you can also pass here like this, right? So even if you want to create, if you don't want to use the students, you can also create like this. std2 equals to this. You can also pass std2 here. So these are the different options. You can directly use a student. You can create a variable, right? But based on the value is nothing but it's an object of a student type. So this student std variable type is automatically going to be student. Even you can directly pass the student object here. So these are the different ways how you can add a complex object, right? You can create a complex variable. That variable you can add it here. You can store that object inside a var data type. You can add also that here. Even you can directly pass an object to this NQ method. That is also possible, right? And then I'm using a for each loop to access all the elements, right? You can see this thing, right? So if you are working with a multi-threaded environment, right, where you want this collection to be used or accessed by multiple threads, either for adding element or for removing the element or for any kind of operations, right? Then in that case, you need to use concurrent queue instead of queue. Clear, guys?
Yes, sir.
Sir, yes, sir.
Okay, the next one, what we are going to see, these are I'm going a little fast. Why? Because this thing we have already discussed 2 times, right? One within our non-generic stack and queue, we have already discussed the same thing in generic stack and queue. Again, I'm going to discuss the same thing with the concurrent stack and queue. We just need to understand the difference between them, right? Functionality wise, they are going to do the same thing internally. Internally, they are going to follow the same LIFO and FIFO principle, right? The difference is that The non-generic stack and queue, they are operating on which data type? Guys, tell me.
Object.
Object. If they are operating on object data type, then what are the advantages and the disadvantages we have?
Performance issue, boxing and unboxing.
Performance issue one is disadvantages. Any other disadvantages?
You have some kind of compile errors due to incorrect data types.
No
Runtime errors.
compilation error, runtime error, right? Due to type mismatch, you might get runtime error. Compilation error means what? You can store any type of data. You will not get any compilation error, right? And we can overcome those problems using using our generic stack and generic queue, right? Then what is the problem with the generic stack and queue? Can anybody tell me?
Thread safe.
They are not thread safe, right? They are not thread safe, right? And as they are not thread safe, you cannot use that collection by multiple thread. If you are using that collection by multiple thread, then you will get a different kind of unexpected output. Give me 1 minute, guys. Right, so threads and how and all those problems, right, that generic and non-generic collection classes you can overcome here you can achieve thread safety, you can achieve you will not achieve boxing and unboxing because it is generic, right? You can see it is generic means that boxing unboxing, that type mismatch, those issues are not available here. And even this is also thread safe, right? Then you might be one question, sir, then as it is thread safe, right, as it is not providing any kind of a type mismatch error, as it is not providing, right, any kind of a boxing and unboxing, then I can always use this concurrent collection classes over their counter but I mean over generic and non-generic collection classes. No, that is absolutely, the answer is no. Why? Now see, based on the scenario, you need to decide which collection class you need to use, right? If you are developing a single threaded application, right, where the collection class is going to be used by a single thread only, then in that case, you should use generic collection classes, right? Why? Because see, internally to maintain the thread safety, internally it is implementing some kind of a locking mechanism, right? Internally it is implementing some kind of a locking mechanism, right? As internally it implements some kind of a locking mechanism, that will take some time. If you are not implementing, if you are not developing a multi-threaded application, if still in a single threaded application, if you are using this concurrent collection, right, that external locking mechanism of the what it is implemented internally, right, that extra locking mechanism is also going to be executed when you add any element or when you remove any element from the collection, which is going to take some time, right? We cannot compromise with our performance, right? So basically, whenever you are going to develop any kind of application, right, three things you need to take into consideration, right? So always remember three things when you are developing any kind of application. First thing is business logic, right? So what kind of a business logic you want to implement, you should implement and you should get the expected output, right? The business logic should be proper, you should get the output as expected, right? The second thing that you need to consider is security, right? There should not be any security hole, right? If you are developing any kind of application, your data, what you are transmitting over the internet, right, should be secure. Your data should be secured in the sense your data should be encrypted, right? Your data should be encrypted, right? You should implement authentication and authorization, right? You should implement authentication and authorization. What it means, now a valid user with proper author or proper accessibility can access my resources, right? And you should implement some kind of HMAC. You can say HMAC. HMAC means from proper source, right? From the proper source, the request should come, right? So it should be that if my client is ABC from ABC server, I should get the request, not from any other one. And the third thing is, which is very important, is performance, right? The performance of the application should be good. If your application taking more than expected time, then nobody is going to use your application, right? First of all, the business logic should be there, right? Whatever for what purpose you develop the application, that purpose should be fulfilled. Second thing is security, right? You can implement encryption, decryption, right? The data transmitted over the internet is going to be in encrypted format. So if any hacker or if middle person wants to see your data, then he should only see the encrypted data and he should not decrypt the data, right? And authentication and authorization, the person who is accessing my resource, that person should be authenticated one, and that person should have right or access to that particular resource. And you can, nowadays you might know something called token based authentication, right? Token based authentication, or mostly nowadays what we are using, JWT, right? JSON Web Token, right? HMAC means it is a hash-based message authentication, right? So whenever the client send a request, it will generate a signature, right? And at the server end, right, you will also again, by taking the actual data, you will again generate a hash code, and then you will compare whatever the hash code sent by the client and whatever the hash code I'm creating here is matching or not. If matching, then it is a valid request, so that you can proceed further, and then you can going to check authentication, authorization, all these things, right? Performance means your application should be good at performance level, right? It should not be take more time to provide the output, right? This is the thing that you need to remember, right? Performance is one of the criteria, right? And in the case, if you are developing a single thread application and if you are going to use concurrent collection, then your performance is going to be degraded, right? That should not be the case. So anyone working in industry, right, they might be know the importance of these three things, right? Apart from this thing, nothing is there. One is business logic, that code you have to write, you have to provide security to your code, and you have to develop performance based applications, right? Clear, guys?
Yes, sir.
Right? So how many of you know these things? Anyone have ever implemented this encryption, decryption, authentication, authorization, HMAC on any of your application?
Yeah, yes.
Yeah, I have some, yes.
Right? So then you might know what is the importance of this thing from the security point of view, right? So basically, if you are developing a
biometric authentication.
sorry.
We are using for security purpose. We have separate login IDs, usual login IDs for all the authenticated users, and also we use biometric authentication.
Okay, right,
Yeah.
right. So basically, what I mean to say is, if you are developing one application, means security should be there. If there is no security, then that application is not going to be used by any client, right? Client means you should validate the client, right? A authenticated person should access the resources, right? Unauthenticated user should not have rights to access the resources, right? That is what you have to implement, right? That is the part of authentication and authorization. Apart from that, you should sometimes, right, because I'm working on a banking application, right, we are providing 3 layer of authentication and authorization, right? We are using JWT authentication, right, for validating the user, right, and validating the user and client. Then we are also whatever data we are providing over the internet, we are also implementing that encryption and decryption. Even we are also implementing HMAC, right? 3 layer of security we are providing in our application. Basically, I'm working on a project which is basically for a bank, right? So providing this implementation. But the behind the scene, one more point that you need to remember: if you are providing this 3 level of securities to your application, then there is a little performance integration, right? Because this is the extra layer you can consider, extra thing which you are providing to your application, right? As security is high, there is a chance of the performance is to be degraded, right? But that is acceptable, right? If you are providing good performance, then you have to compromise a little bit with your application performance. But that is fine. From the security point of view, you can compromise for the performance of your application a little bit. For the coding point of view, you should not compromise your application performance, right? Okay. Now if you look at this concurrent queue class, then this is exactly the same. Concurrent stack means it is exactly the same as your generic stack of T. So generic stack of T belongs to system.collections.generic namespace. Generic stack of T was introduced as part of C# 2.0. Generic stack of T works on the principle of LIFO. Right? That means what? Now, whenever you want to access last in, first out access to the collection of a last in, first out collection to the elements of a collection, right? Then you need to use that you need to use that generic stack, right? But when you need to go with the concurrent stack, now the generic stack will not provide thread safety in a multi-threaded environment, right? If you want to achieve the same functionality what is generic stack provides you with the thread safety, then you need to use concurrent stack, right? Concurrent stack means it is a collection which is introduced as part of C# 4.0, and it is belongs to system.collections.concurrent namespace, right? The difference between the concurrent stack and the generic stack is that the generic stack collection is not thread safe, while the concurrent collection, the concurrent stack is thread safe. This is the only difference, right? Apart from this difference, there is no more differences between concurrent stack and the generic stack, right? So you can see here I'm also having two overloaded version of the constructor, right, which you can use to create an instance of the concurrent stack. And while creating the constructor instance, right, you have to specify the type, which type of elements you want to store inside the concurrent stack collection. That type can be any built-in data type like integer, double, string, character, right? Or any user-defined data type like customer, student, employee, product, anything you can pass as a type to this concurrent stack. Then how to add element? Here we are having some twists, right? Here we are having some twist, right? In earlier cases, right? On earlier stack, generic stack, we are only having the push method, right? We are having the push method means what? You can add one element at a time. But now, right? But with this concurrent stack, we are having two methods. One is that push method that is available where you can add one element from the at the top of the stack, right? Top of the stack. Even though you can add one element using the push method, now it is also possible that you can add multiple elements, and for that you need to create one array, right? And what type of array? It is a single dimensional array, and you can provide that single dimensional array to this push range method, and this push range method is going to add that collection, right? That array at the top of the collection, right? I will show you example of both this approach so that you will get better idea. For example, suppose I'm creating a stack to store the countries, right? So I can create a concurrent stack, and I'm specifying the type as string. Then you can see I can store in string values, right? But when I is trying to store integer values, I will get compile time error. Why? Because this 100 is not a string value, it is an integer value. And here we explicitly specify that we are going to add string values. And here this is not a string value. This is the reason why it is throwing me compile time error right now. Now, as we mentioned, this push range method taking one parameter of a T array. T means what? String. Suppose in this case, if you are taking this example, the here what is string? Here T is nothing but string. So basically for this push range method, if I want to call on this concurrent stack collection, then I need to pass one array of which type? Can anybody tell me?
String type.
String array, right? I have to pass one array of string type. So here you can see I'm creating, and I have discussed you many ways to create an array, right? So here I'm creating an array by using the collection initializer syntax. And here this is my country array. Now what I can do is now I can call this push range method on this collection, and to this push range method I can pass my array. So this is a one-dimensional array you can see, and to this one-dimensional array I have added two elements by using the which method? By using the collection initializer, right? And these two elements will be added at the end of the stack, right? India, USA. After USA, it is going to add UK, and then it is going to add New Zealand, right? We cannot add elements into a concurrent stack using collection initializer. Why? Now this concurrent stack class doesn't have the add method, right? As it doesn't have the add method, you cannot add element to this concurrent stack using the collection initializer. And how to access the element means by using the for each loop. Even again here you cannot access the element by using a for each loop because this collection class doesn't have any indexer. Right now, if you go to the concurrent stack definition, then you will see that there are two overloaded version of the constructor. Whichever you want, you can use. Now, if you go to the add method, right, you can see one is add method, one is push range method, another is push range method of T. So I'm going to show you example of these two, and this is exactly same. So in this case, right, this is the adding method, and this push range method, right, as it is introduced in 4.0, they are providing the flexibility. Suppose you are having one array and you want to add in this array, suppose you are having 10 elements. This array having 10 elements, and you want to add this element at a particular index position, and you want to add only 5 elements, then what you need to provide? You have to provide this array. Let's say from the index position 2, I want to add, and I want to add 5 elements, right? Then from this array, 5 element it will take from the starting position, and it will insert those 5 elements at the index position 2, 3, 4, whatever you specified here, right? So you can see this is the push method, and in this case it will insert all the elements at the top of the collection. In this case, it will not insert the element at the top of the collection. Rather, it will insert the element at this index position what you specified, right? But now internally the logic has been written here, right, by this push range method, right? Internally you will select where to add the element, right? And for this internal architecture, they have written the logic, right? They have the flexibility that what elements needs to be added, how many number of elements needs to be added, and from what index position the elements needs to be added. Those logic have been written inside this push range method, right? Now you can see. So here I'm adding this element push. I'm using this push method to add two elements. I cannot add this 100 because 100 is a integer data, and we are creating this collection to store string values, right? You cannot add. So currently I'm using for each loop to show the elements. So in this case, you can see first USA, then India, because from the top position only it is going to fetch the element, and top is USA and then India. Then I'm using this countries array, and in this countries array, I'm adding two elements, right? I'm adding two elements, UK and New Zealand, right? And then I'm using this push range method. Then you will see that New Zealand will be written first, then UK, then USA, then India, right? Now let me run the application and show you the output. See, New Zealand first, USA, India, then New Zealand, UK, USA, and India. So why New Zealand first, then UK? Because it is following the top approach. Top approach means from the top position it is going to return with the array. Now I'm going to show you the other overloaded version, right? Suppose here I'm adding some country called CAN, countries array to SL, right? I'm adding few more elements. Okay, let's give us ABC, PQR, XYZ, right? Now I'm going to use the other overloaded version, which is taking 3 parameters, right? So to this method, I'm passing this, right? I want to add the element from the index position 2, and I want to add 3 elements, right? So from the index position 2, I want to add from index position 1, I want to add 2 elements, right? So in this case, if you look, okay, let me first run the application. No, I have not written the for each loop. Right? See, in this case, this country having how many elements? Guys,
5.
5 element. From this index position 1. So in this case, which one is the index position 1?
SL.
Yes.
Sorry?
SL.
SL, right? Index position 1 is SL. And how many elements I need to pick from this array?
2.
2 elements. 2 elements means SL and
ABC.
ABC. So from this array, from this index position, this number of elements I need to add, right? So in this case, SL and ABC is going to add in which collection?
Current stack.
Concurrent stack. That means in this case, this is the last element and this is the previous last element. So you can see ABC, SL, and then the rest of the element, right? You can see ABC, SL, then New Zealand, UK, USA, and India. Is that clear? Guys?
Yes, sir.
Yeah.
Clear?
Yes, sir.
Okay. Let me replace this example with the latest one because we have modified the example. See, if I'm not providing the example of each method, right? Sometimes you need to do some kind of research, right? So see, previously I have not included the example for the third overloaded version, right? But I'm showing you here, and you have to understand these things, right? So right? Okay. Now, how to remove elements from the first of all, you understand this thing, right? How to add elements. So we are having push method, right? We are having push range method, and we are having push range method, right? Where we can provide an array. So in this case, all the complete array will be added. But in this case, the complete array will not be added. Here you have to specify. Here I'm specifying from what index position and how many elements I want to add to this collection, right? So now this example is clear, right? What is the difference between these 3 methods? Yes.
Yes.
Right. So now we are having the concept, right? How to remove elements. So first of all, if you want to remove elements, the elements will be removed from where? From the top of the stack, right? That means whichever element added last, that will be removed first, right? So, and you can see here we are having 2 options. So try pop method. See, we have already discussed pop method in our generic stack class. So here we are not having pop. Here we are having the try pop method because it might be possible that 2 threads trying to remove the element. So it might be possible that one element, right, is there and one thread remove that element while other thread also trying to remove that element. Then in that case, it will not give you error. It will give you that it will return you null, right? So what it means suppose you try one element is there. One element is there in the collection and 2 threads trying to remove the element from this collection. Then then among the 2 threads, one thread will able to remove the element, and the thread which is able to remove the element for that thread, right? This try pop method is going to return true, and that remove the element will be stored inside this variable. Clear? For other thread, this type of method is going to return false, and in that case, this result variable will store the default value based on the data type. If the data type is integer or numeric, the default value is going to be 0. If data type is boolean, right, the default value is going to be false, and the data type is reference, then the default value is going to be null. Clear?
Yes, sir.
Yes. And this try range method means it is going to do the same thing, but in this case, you have to specify one array, right? And that array means some of the elements, and those elements is going to remove from the collection, right? Let me show you this example practically so that you will get more clarity. Right, so in this case you can see I'm creating a stack, I'm adding few elements, right? And here I'm adding I'm displaying the elements. I'm try pop result means the Brazil element in this case will be removed. So in this case this is the top element. So this is the top element, and in this case it is going to return me true, it's removed true, and in this case it is going to return me Brazil, right? And in this case once I look through this, then you can see these 5 elements, Brazil is removed, right? So now what I'm trying to do, I'm trying to remove countries, to remove UK, NZ and Brazil. So UK is there, Brazil is there, right? UK, NZ and Brazil. UK, NZ, Brazil, right? So in this case, what will happen? Now it will try to remove these 3 elements from the collection. So in this case, I'm passing array to this top range method, right? So you can see the other overloaded version is taking try pop range method, which is taking one-dimensional array, one-dimensional array of a T type. So here T is nothing but what? T is nothing but here string. So basically I need to pass a string array. And here I'm specifying what are the elements to be removed from the collection, right? If the elements are available, then that element is going to remove and it will return me the number of, right? It will return me the number of elements removed from the array, right? Elements removed by the top range method, right? So if the elements are removed, the count it will return, and after removing the element, I'm just using the method, right? The countries to remove. So this is not required, right? This is not required because we can see we are trying to remove this element, and okay, if you want right, because some of the element is not available, New Zealand is not available. If not available, then it is not going to give any kind of error. If not available, simply it will I mean simply it will ignore. UK is available, yes, UK is available, that element is going to remove. Brazil is available, but Brazil is already removed by the previous statement, so you cannot see that element. So instead of Brazil, let me put Canada here, right? So you can see this element is not available. This element is already removed by the previous type of method, and this UK and Canada elements are available, and you can see those elements is going to be removed, right? Let me run the application. What happened? Try range return for concurrent stack elements. Countries to remove. Oh, okay, okay, okay. right? So actually my understanding is wrong. Now I can explain you this thing clearly, right? So any question related to this type of method? I will explain this one again. But now I'm asking any question related to this type of method, how it is working? Guys?
No,
No,
that is
sir.
clear.
No. So what exactly happening in this type of range method means you need to provide one integer array, right? Integer array means say in this case you are specifying a single variable, right? Why? Here you can say this is a single variable, this is a string variable, and in this case why you are specifying a single variable? Because this type of method is going to remove how many elements?
One element.
So one element means you need a single variable, and that element what it is removed, that element will be stored inside this variable. Clear?
Yes, sir.
In this case, this type of range method, right? This type of range method is not going to remove a single element. It is going to remove a range of elements, right? So how many elements this method is going to be removed? That basically you need to specify by using an array. And you can see here I'm creating an array, and in this array I'm specifying the size of the array is how what I'm specifying the array size as 4. So 4 means this type of range method is going to remove 4 elements from this collection, right? 4 elements from this collection. In this case, Brazil is removed. In the next case, these 4 elements is going to be removed, right? Let me specify 3. If I'm specifying this as 3, then how many elements is going to remove? 3 elements from this collection, and those 3 elements it will store inside the string array, and those elements you can see here. And after removing these 3 elements, the rest of the 2 elements you can see here, right? Now let me run the application. See, initially my collection having 6 elements. Using the type of method, I have written 1 element, right? That element is Brazil, right? You can see Brazil is removed from this collection, right? And then after removing Brazil, these are my collection. Again, Japan becomes the top element, right? Then I'm removing 3 elements by using the type of range method. Since this Japan, Canada, UK, these 3 elements will be removed. You can see the type of range remove these 3 elements. These 3 elements is stored inside my string array. And after removing three elements, USA and India, these 2 elements will be there inside the collection. Clear? Guys?
Yes.
So basically to this method, I just need to pass. So in this case, I need to pass a single variable because this method is going to remove a single element. And to this method, I need to pass an array because this method is going to remove a range of elements. And what is the range that you need to specify while creating the array? And here I'm specifying the range as 3. So this method is going to remove 3 elements, right? Those 3 elements will be stored inside this array, and you can print or you can check those elements by using this loop and going to this collection, right? So let me copy this one. Right, let me run this application, take the output. Clear, guys?
Yes,
Yes.
sir.
Okay, so you understand how to remove a single element and how to remove multiple elements. So for single element, you have to use type of method, and if you want to remove multiple element or range of element, then you have to use a type of range method. And to this range method, you need to pass one array specifying the size or the number of elements that you want this method to remove from the collection. And those elements are going to store inside the string array, right? And then you can access those elements. So this is how you can remove elements. Now how to get the top element? So we have two options. One is you can use try pop or try pick. So what is the difference? The difference is that in the case of a try pop method, it is going to return the top element, and by removing that element, right, it is going to return and remove that element from the top of the stack. And in this case, this try pick method, it is it is going to return the element from top of the stack without removing that element. So in this case, the try pop, you can see here, I'm already showing you the example of a try pop. So this element, Brazil, which is the top element, it is going to return as well as removed from the collection, right? And if you use try pick method, right, then that element is going to return, but without removing that from the collection. Already we have discussed this in our previous sessions, right? So when we discussed generic stack, at that time we have discussed, right? So this is my original collection, printing the element of my original collection, removing the element by using the try pop method, right? So in this case, you can see Japan is the top element, so it is going to return me true, and it is going to give me guys one. Right, so basically in this case it is going to return me true, and this is my top element Japan, right? So Japan will be removed, and apart from Japan, all the elements will be printed in this for each loop, and then I'm using a try pick method. So in this case now Canada, once you remove this element, Canada will become the top element. So in this case you can see it is going to return me true, right? As well as and it is also going to return me Canada, right? So in this result variable, Canada will be stored, right? And this Canada element, it is returning but without removing it. And then you will see, once I use the for each loop, you will again see this Canada element, right? Let me run this application. See, Japan, Canada, UK, USA, India, true. Japan is removed. After removing Japan, Canada will become the top element. Canada, UK, USA, India. Try pick method return true. Try pick method return Canada. But this Canada will not be removed from this collection. Again, when I'm using for each loop, you can see Canada element is still there. Clear? Nice.
Yes.
Okay. So now the complex type example, again, whatever operation we have discussed so far, right? Those operation, right? Okay, if you go to this class, you can see try pick. So clear method, no need to explain. You know what is the use of a clear method. Push range, push, we have discussed. Try pick, try pop, right? To array, we have already discussed this thing in our previous session. Previous session means to array, to dictionary, to list. Already we have discussed, right? Now let me show you one example of complex type. So here I'm creating one class called student, having three properties: ID, name, and the branch, right? Then I'm here directly adding the element, right? If you want, you can create a object, right? And you can add that object like this, right? Suppose you want like this, student std1, right? You can write like this, and here you can pass student to 1. Instead of student, you can also write where, that is also going to work fine, right? Then, and using for each loop, I'm just printing the details, right? Printing the element of the collection. I'm getting some error. Why I'm getting this error? Now, as per the C# syntax, every statement should be ended with a semicolon. So here I'm creating the statement, but I have not ended the statement with a semicolon. So I put the semicolon, and now it should work fine. Okay, let me run, and you can see the element. So this is how you need to work with the concurrent stack, right? Then what is the difference between stack of T and the concurrent stack of T? So it is not a thread safe. If you are talking about the stack of T, then that collection is not a thread safe, but this concurrent stack of T, it is
thread shape. This is one of the difference, right? It has a pop method to remove the last inserted item from the collection. Concurrent stack has a try pop method to remove the last inserted item from the collection. Here pop, here we are having try pop. Stack of T can add a single item at a time using the push method. Concurrent stack of T can add multiple items at a time. So here we are having push method, but we are also having what method? Try push method, right? If you are using try push range, then in that case you can do. We can add multiple items by using the push range method, right? And here you cannot have that option so that you can add multiple elements. You can remove only single item using pop method, but here you can remove single element using try pop method. Even you can also have the flexibility to remove a range of a method by using the try pop range method, right? We can remove using pop method, and here we can remove using try. So basically the difference is that it is thread shape. It is not thread shape, it is thread shape. Here in stack, right? In stack, you can only insert a single item at the top of the stack. In concurrent stack, you have two options. If you want to insert a single element, you can insert single element using the push method. If you want to insert range of element, right, that is also possible by using the push range method, right? And in the case of stack, you can only remove a single element from the top of the stack by using the pop method. Here you have two options. You can remove a single element by using try pop method, and you can also remove multiple element by using the try pop range method. Is that clear? Yes.
Yes.
Okay. The next, what we are going to, so we have discussed dictionary, right? We have discussed queue and we have discussed stack, right? Then there should be something similar to what collection we have not yet discussed. So basically we are having four types of a collection. One is stack, which is following what principle? Guys, tell me. If I'm using stack, then it is following what principle?
First in, last out.
Sorry?
First in, last out.
Stack, first in, last out, right?
Before.
No, LIFO.
Before.
This is last in, first out, right? Queue means what? First in, first out. The person who is entered into the queue first will be the person to be removed from the queue first, right? Dictionary means what? You have to store the data in the form of a key value pairs, right? And one collection is there, list, where you can store and access the element, right? By your own way, right? By using the index position, right? By using the index position, you can store the element, you can access the element. We have discussed this stack means concurrent stack. We have discussed concurrent queue. We have discussed concurrent dictionary. We have discussed. Now we are going to discuss the list collection. List means what is the class available in concurrent dictionary which can serve as a list, right? Whatever functionality we have achieved using a list, if you want to achieve those functionality in concurrent dictionary, then which class is provided there? There is a class called ConcurrentBag. That is what we are going to discuss. Right? See, the ConcurrentBag is a thread shape collection class. Like other collection class, right? Other concurrent collection class, this is also introduced as part of C# 4.0, and it is a concurrent class. It belongs to system.collections.concurrent namespace. It allows generic data to be stored in an unordered form, right? Unordered form means there is no specific what you can say order, right? On the way you are adding the element, in the same way the element is going to be added. That is nothing but unordered list, you can say, right? And in this case, you can also store duplicate object, right? See, in stack, you can store duplicate. In queue, you can also store duplicate. In list, you can store duplicate. In dictionary, right? The value you can store duplicate, but the key must be unique, right? And if you want to store some unique values, right, then you have different types of a collection, right? Sorted set, yeah, hard set, we have discussed, right? They are going to store unique values. And the working of a concurrent bag is very much similar to the working of a generic list T collection, right? So basically what this concurrent bag is very much similar to list of a T. Then what is the difference between them? The difference between them is this collection class list of T, it is not a thread safe, where concurrent bag of T, it is going to be thread safe. So we can use generic list class instead of concurrent bag with multiple thread. But in that case, see, if you are not using concurrent bag, then you can still use list of T. But in that case, as a developer, as a programmer, right, then you need to take the responsibility to provide thread safety by implementing the thread synchronization mechanisms, right? We have already discussed what is monitor class, what is semaphore sleep, locking, right? Those things you have to implement manually as a programmer, right? Then, but if you are using concurrent bag of T, then those things are internally managed by the collection class. So as a developer, we need not to be worried about how to provide thread safety to this collection, right? That will be internally managed by implementing the best synchronization mechanism, which should provide you the best performance, right? That logic they have already implemented, and you should not be worried about those things, right? You simply use the concurrent bag, right? And the rest of the thing to provide the thread safety is internally taken care by the framework, right? And if you are not interested in concurrent bag, right, then as a developer you can still achieve thread safety with list of T, but in that case you have to write the additional statement, right? Create a log object, right? Then use the log keyword, provide the log object to that method, right? Log, then you have to write the code. All these things you need to do manually, right? If that collection is used by multiple method, right, then you have to write the same logic, same locking logic at multiple places, right? If you are writing the logic at multiple places, then it might be possible that it's a time consuming task, first of all, because you are writing the same thing again and again, right? Later a new method introduced where you also need to provide the thread safety, right? Again you have to write the same logic there. By mistake, if you forgot, right, then it is going to be give you some kind of a error, right? So basically the ideal scenario is that if you are working with multi-threaded application, then you should use concurrent collections, right? Then how to create instance means, again this class having two concurrent constructor, you can use any of this constructor to create an instance, right? In this case you can pass a collection, and in this case this is the zero argument constructor, doesn't take any parameter, it is going to create an instance, and the rest of the thing you can do, right? So first of all you need to import the namespace, from which namespace this class belongs to, that you need to import. And we know from this namespace system.collections.concurrent namespace, this concurrent bag collection class belongs, right? Then you have to create an instance, right? Like other concurrent classes, while creating the instance you also need to specify the type. This type can be any built-in data type like integer, character, float, double, etc., or any user defined data type you can also provide, like customer, employee, product, report, right? Anything like this, right? Then how to add element, you can see by using the add method. Now you guys can tell me, as this class having the add method, right, to add the element, can we use collection initializer in this case?
Yes.
Yes, you can use collection initializer, right? So you can see this is the add method, right? This method is used to add element to the concurrent bag, right? And this T can be null for which data type?
Reference data.
But if it's a primitive data type, then you cannot pass null, right? Reference data type means what? Now the type which is class type, right? That is nothing but a reference data type. And for that type, you can pass the null value. But for reference data type, you cannot pass null value. See, I'm creating a collection to store countries. So I'm specifying the type as string. Here you can see I'm adding elements, string element, that is fine. While I'm adding some integer elements, it is giving me some compile time error. Now you can see I'm initializing this collection also by using the collection initializer, because this collection class having the add method, which is taking T as a parameter. And this T is nothing but the type that you specify while creating the collection. So here T is string means you can pass here. You can see here I'm creating the type as string, so I can directly pass some string values. That is fine. Right? How to access the concurrent bag element means we can access the element by using the for each loop. Right? Now let me show you one example and try to understand these things. Right? Let me go to the definition. You can see this is the for each loop. I can access you can see there are two constructor. Using these two constructor, you can access you can create an instance of this class by using either this constructor or this overloaded version, which is taking enumerable of T. So what is enumerable to of a T collection means you need to pass a collection which should implement this enumerable of T. So here you can see there is something producer consumer collection, which we are going to discuss after some time. And you can see this collection implement enumerable of T, right? So you can, if you are having a collection of this type, then you can pass that collection to this method. And you can see this is the add method. Because of this add method, right, we are able to initialize the collection by using the what? By using the collection initializer. And this collection doesn't have any indexer, right? So you can see I'm using the add method, right, to add the element, and I'm just printing the element, right? Even see in this case, the second collection, right, the second overloaded version, which is taking enumerable of T. So here you can see I'm creating an array, right? I'm creating an array, and I'm creating a collection. I'm using the other overloaded version in this case. I'm passing that array to this collection. This is also possible. Now, if you go to the array class, see, it is implementing the enumerable, right? So as it is implementing enumerable, so you can create an array and you can also pass that array to this class. But here, what type of a data this array storing, that should be compatible with this one, right? Even suppose this is your concurrent bag, right? If you want, you can directly pass that also here. That is also fine, right? Because if you go to this concurrent bag, then you will see that this is also implementing enumerable of a T, right? So anything, so any collection which implement enumerable of T, you can create a collection of that type and you can pass that collection to this, right? Is that clear, guys?
Yes.
Yes, sir.
Right. So now if you run the application, then you will see that both the collection is going to give you the same output. Here I have created, in the past I have created the collection adding the elements, and in this case that collection I'm passing as a parameter to this concurrent bag too. So both the collection having the same element, but both are different, right? But both are different. Both are having different memory. In this case, this collection element are coming from the previous collection. In this case, I'm creating the collection and adding the element. Clear? Guys, is that clear?
Yes, sir.
So the point that you need to remember while I'm creating the collection, right? You can say enumerable of T collection. So enumerable T of collection means what? First of all, tell me what is this. So whenever you see something as I means what? It is an interface. So it is an interface. You can see it is an interface. And this is also implementing what? enumerable. So whether it is implementing this or this, you can pass that as a parameter. And coming to this class, right? enumerable means it is a reference variable. So think that any class which implement this enumerable of T, then that class is a child class of this interface or not?
Yes.
So that means this is the parent reference variable, and the class what we have created by implementing this interface, that class is nothing but a child of this one. Then can I store a child class object under a parent reference variable?
Yes.
So this is the reason why you can pass any collection as a parameter to this class constructor, and that class if implementing this enumerable of T, or if it is implementing in enumerable, right, then you can pass that collection as a parameter. So in this case, if you go to ConcurrentBag T, it is implementing enumerable T and enumerable, right? And if you are passing that array, right? If I'm creating an array, right? So then in this case, this is an array. So this array means it is inheriting from this array. You can see it is also implementing the enumerable. So as it is implementing enumerable, so you can pass this array or you can pass this collection. Here it is also implementing enumerable. Here also it is implementing the enumerable, right? So now try take method. So how to remove elements from the concurrent bag, right? So in this case, they have provided one method called the try take, and this method attempts to remove and return an object from the concurrent bag collection, right? Like the try pop method, right? Or the try pick try pop method. So this try take method is going to do the same thing, right? This method attempt to remove and return an object from the collection, right? And in this case, if this method return, if there is an element and if it is removed that element will be stored inside this variable. And if there is no element, right, then this result variable is going to store the default value based on this T type, right? And second thing, if it is remove the element, then in that case, this method is going to return true. And if it is not removed that element, means if the collection is empty, right, then in that case, this try take method is going to return me false, right? So if bag is empty, then it is going to return false. In other cases, it is returning true. And in that case, that element, that removed element will be stored inside that out variable. So here I'm creating, okay, this collection, this is not required. Right. So in this case, this is my concurrent bag, right? I'm adding few elements to this concurrent bag using the collection initializer syntax, right? And I'm using a for each loop to loop through all the elements, right? And here I'm removing the element by using the try take method. In this case, the method will remove the element India from the collection, and that will be stored inside this result variable. And in this case, this is removed and result, it is going to return true, and this is going to contain the removed element. And after this, I'm just looping through the collection to make sure that element is no more available in the collection, right? Let me run the application and show you the output. You can see initially this is my collection Canada, UK, USA, India, right? So Canada is the top element, that element is removed, right? In this case, India, USA, UK, Canada. The Canada is the top element, right? That Canada is the top element, that element is removed. And in that case, you can see the rest of the all elements are there, right? Any question? So this is exactly same as your try pop method. Clear? Guys?
Yes.
Okay. How to get the element from the concurrent bag, right? So you can use a try take method or you can use a try pick method. So what is the difference? Now, in the case of a try take, it is going to return the top element, but in that case, it will remove that element from the collection, and it is going to return false when the bag is empty. And if bag is not empty, then it will remove the element from the top and it will return true. So in try pick method, we have already discussed try pick means what? Now it is going to return the element from the top without removing the element, right? If the if there is element, if the bag is not empty, it is going to return true. If the bag is empty, then it is going to return me what? It is going to return me false. Right, so you can see this is my concurrent bag. This is my original elements. I'm printing by using the for each loop. and here is removed, right? Try trick means result 1. So it is going to remove the top element, right, Japan, and once it removed the top elements, right, it will return true, and that top element will be stored inside this variable. And after then you will see that the top element will be removed from the collection, and in this case I'm using a try pick method, so it is going to return me the top element without removing the element, right? Let me run the application and show you the output. You can see Japan, Canada, USA equal India, so it is removing the Japan element. After Japan, you can see the rest 4 elements are there. Try pick method remove the Canada element, but you can see Canada it removed, but it is not it returned the Canada element, but it is not removed from the collection. Clear?
Yes.
Guys? Yeah. Right? How to convert? Right? So how to convert a concurrent bag to an array, right? We have already discussed these things, right? If you want to convert to an array, right, then what method you need to call? To array. So this is my concurrent bag, and I'm just calling the to-array method, so it will convert that bag to an array, right? And then I'm printing that array element. So you can see this is my concurrent bag, printing the elements of concurrent bag, converting that element concurrent bag to an array, and printing the element of the array. And how I'm converting? By calling the to-array method, right? So you can see both are going to contain the same elements, right? Any question from this example? This is very simple. You just need to call the to-array method. That's it. And now I'm going to show you the example of using complex type. Right, so you can see this is my concurrent bag, and here I'm adding student type and printing the element. Rest of the operation what we have discussed so far, right? You can also do all those operations on the complex type also, right? You can see this is the output, right? Any question from concurrent bag?
No, sir.
Okay. So the last one, what I'm going to discuss is producer consumer pattern, right? So producer consumer pattern. Okay, let me explain you what is producer consumer pattern, right? Then I will explain you how to implement, right? So this blocking collection is basically it is a thread shape collection class, right? It is basically used to implement the producer consumer pattern, right? It provides feature bounding and blocking to support producer consumer pattern. What is bounding and what is blocking we'll discuss, right? Let us try to understand. So producer consumer pattern means what? So let's assume you are having a producer thread, and you are having a consumer thread, right? So producer and consumer pattern means what? That you must have 2 threads. The producer thread role is to add element to the collection, and the consumer thread role is to consume, or you can say remove element from the collection. Elements from the collection. So consumer thread is going to consume the element, and the producer thread is going to produce the element, right? But here is the situation. Suppose you have said the collection max length is 100. So you have said the collection max length is 100, right? And simultaneously, as soon as you are adding the element is going to be consumed by the consumer thread. Then what is the scenario, right? The case 1 is, right? This is one of the scenario, right? You are adding the element and the consumer is consuming the elements, right? But there might be some scenarios, right? What scenario? Now, one use case. Use case is that the collection, you set the maximum length as 100, means maximum 100 element you can set. If you set the, if the collection reached the maximum length, right, then this producer thread will be going in the sleep mode. If the collection reaches the maximum length, producer thread will go into the sleep mode, right? You understand? If the collection reaches the maximum length, means if the producer added 100 elements, right? Then 100 elements means in the collection currently 100 elements are available. Then the producer cannot add a new element into the collection, right? In that case, the producer thread will go into the sleep mode. Then how long it will be there, right? This is the question. How long it will be there? How long it will be in the sleep mode? That basically depend on the producer thread, sorry, consumer thread. As long as, okay, as soon as consumer thread, consume any element, right? So what it means now, in this case, once it reaches the maximum length 100, right? If there is no more allocation to add any element, the producer thread will go into the sleep mode. How long it will go into the sleep mode? As long as the consumer, as soon as the consumer thread consume alien. For example, currently maximum 100 elements is there, right? For this case one, right? For this case one, consumer consume one element. So as soon as consumer consume one element, the maximum length will become what? 100 is already, so it will become 99. As soon as it becomes 99, this producer thread will active. Again, it will start adding elements to this collection. You understood, guys? So
but size, how it will get to know this maximum length is this much?
We have to set, na?
Okay.
If you are setting this, then that maximum length is 100. If you are not setting anything, then there is no length. As soon you can add any number of element, there is no issue. But this optional length you can set.
Okay.
Right. So in this case, that means what? Now, if you are setting any maximum length, it will at any point of time, maximum this number of elements it can hold. And once it reaches the max, right, then it will be going to the sleep mode. And again, it will make active when the element, any of the element is going to consume by the consumer thread, right? In some scenario, it might be possible that, right, in some scenario, it might be possible that the bag is empty. That is, the collection is empty, right? Some scenario, the collection is empty. So if the collection is empty, right, then what will happen? If the collection is empty, then the consumer thread will be going to the sleep mode. If the collection is empty, then the consumer thread will go into the sleep mode. Can anybody tell me how long it will be in the sleep mode? Can anybody tell me how long it will be in the sleep mode?
Until first element is added.
No, and as soon as, not first element, as soon as producer thread add any element. It might be possible that a producer thread added 50 elements, consumer thread consume 50 elements, right? Once the consumer thread consume all the elements, then the collection is going to be empty. Once the collection becomes empty, it will go into the sleep mode. And once the producer thread add any element, again, it will come into the active mode. And these things are going to happen asynchronously, right? That means the producer thread adding the elements parallelly. At the same time, the consumer thread is going to consume the elements, right? Clear or not?
Clear, sir.
Clear?
So one doubt here, like you're saying producer thread and consumer thread. So it's both the threads are similar thread, but the only difference is that producer thread means it is going to add
No,
the
both.
content.
So similar thread means what? It's going to be completely a producer thread means it is a new thread. Consumer thread means it is a new thread. This thread is going to call a different method, and in this thread, this is going to call a different method. But both these thread are going to be work on the same collection. And in this collection, this thread is going to add element, and this thread is going to remove element.
Okay. Good.
Right. So this is how. This is what all about your consumer and producer pattern, right? So in this case, how we can implement this, right? See, the blocking collection implement. See, this is a collection implement the producer consumer pattern with the thread shift, right? So in this case, you might be see, this is my collection, right? And this collection is going to be shared by multiple thread. If multiple thread means what? We need to provide thread safety. If we are not providing thread safety, then there might be some inconsistent output or behavior of the application, right? So if you are using the blocking collection, right, that thread safety for this consumer and producer pattern provided by the .NET framework. You simply use this blocking collection. Rest of the things are going to be handled by the framework, right? There you will not get any kind of thread safety, whether if the maximum length is filled, right? If you are adding element, you will not get any error, because in that case the thread will be automatically going into the sleep mode, right? If the if in this case, if the collection is empty, right, and if you are still trying to remove the element, then you will not get any error. Why? Because once the collection is empty, automatically the thread will be going to the sleep mode. It will not do any kind of a task, right? As soon as the producer adding element, again it will make into the active mode, and again it is going to consume the element, right? So this thread synchronization is automatically provided to us by this blocking collection class. The blocking collection class automatically provide thread safety for this producer and consumer pattern, right? So in producer consumer pattern, we have two threads. One is called producer thread, and other one is called consumer thread, and both thread will share a same common collection class to exchange the data between them. And for this scenario, we can use blocking collection as the collection class, which will be shared by the producer and consumer thread. So in this case, you have to use blocking collection, and this collection is going to be shared by both producer and consumer thread. And this blocking collection class will provide thread safety, so we should not have any kind of concurrency issues or threading issues, right? The producer thread is going to generate the data while the consumer thread is going to consume the data. Generate the data in the sense it is going to add the element to the collection, and consume the data means it is going to remove the element from the collection. We can also set the maximum limit of the blocking collection class. This is optional. If you want, you can set. If you do not set, then there is no limitation of number of elements that can be added into the collection. Right? If you set the maximum limit, then what will happen? And once we set the maximum limit of the collection, then the producer cannot add new objects, right, more than the maximum limit, and the consumer cannot remove data from an empty collection class, right? So once you set the maximum limit, then once the collection reaches the maximum limit, then you cannot add new elements unless some of the elements are going to be consumed by the consumer thread, right? And similarly, if your collection becomes empty, right, if you have an empty collection, then the consumer thread cannot remove any item or consume any element from the collection, right? Then how these things are implemented internally, that is what we need to understand. We understand theoretical concept, right, is what is the producer and the consumer pattern, but now we need to understand, right, how it is exactly implemented, right? This blocking collection has two important features, right? These two features actually help us to implement the producer consumer pattern, which differentiate it from other concurrent collection classes, right? So this blocking collection, what we are going to implement, right? This collection class providing two important features. One is bounding, and one is blocking, right? And these two features is not available in other concurrent collection classes, and this makes this collection class to be different from those other collection classes which we have already discussed, right? This bounding and blocking feature is not available in other concurrent collection classes, right? Then we need to understand what is this bounding and what is this blocking means. See, bounding means we can set the maximum number of objects that we can store in the collection. When a producer reaches, or when the producer thread reaches the maximum limit, it is blocked to add a new object. It is blocked means it is going to be in sleeping mode, right? And when the thread is going to be in sleeping mode, then what it means? It means the thread is ideal. The thread is not going to do anything, right? In the blocked state, right, what will happen? The producer thread goes into the sleeping mode. It will unblock. When it will unblock, as soon as the consumer thread remove object from the collection. This is nothing but your bounding. Bounding means you have to set the maximum limit, and when the maximum limit is reached, right, the producer thread reached, then it is blocked, right? The blocked means the thread will be moved into the sleeping mode, and as soon as it will, as soon as the consumer thread consumes some of the element from the collection, right, again it will be back into the active mode. This is nothing but your bounding. Bounding means setting the maximum, set the maximum limit. Blocking means when the blocking collection is empty, right? Blocking means when the collection is empty, the consumer thread is blocked until the producer thread add a new object into the collection, right? So when the collection is empty, the consumer thread will be blocked. The consumer thread will be in the sleeping mode as soon as the producer thread adds some new elements into the collection, again it will be come into the active mode. Right, so this functionality, this blocking and this bounding is not provided by other collection classes, right? And hence you cannot implement this producer consumer pattern using other collections, and you can implement using this. So bounding means you have to set the limit, and this limit is basically used with the producer thread. Once you reach the limit, the new element you cannot add. And blocking means when the collection is empty, the consumer thread cannot consume any element from the collections. Is that clear? What is meaning by this bounding and blocking? Clear or not? Right?
Yes, sir.
Right. Again, once I start discussing the practical example, you will get more clarity, right? And this thing I'm not discussing right now. I will discuss it once I'm giving you the example, right? So this thing, right, what I'm mentioning here, I will come to this point later, right? So how to create a blocking collection? You know, the namespace, this is the namespace you can use, right? So blocking collection means next we need to create an instance of a blocking collection class, right? So you can use the constructor like this. You need to specify the type parameter, right? What type of data you want to store. I want to store integer, you can specify integer. I want to store string, you can specify string. If you want to store employee, you need to specify employee. And here you can see I'm creating a collection of integer, and here you can see I have not specified the limit, right? So as I have not specified the limit, this blocking collection can store any number of elements. If you want to specify that maximum 100 elements should be added into the blocking collection, not maximum 100 element at any point of time, it can store maximum 100 element, then you need to specify the size by using the constructor, right? And one more thing, guys. By default, see, blocking collection, by default, it uses the concurrent queue as its collection class. Blocking collection means it is going to implement the producer consumer pattern, but internally to store the data, right, and to consume the data, it is implementing some mechanism, right? What kind of a mechanism means what kind of data structure you want to use to store the data. You want to you store data in stack data structure, you can do it. You want to store the data in bag data structure, you can do it. You want to store the data in a queue manner, you can do it. By default, blocking collection uses concurrent queue. So we already discussed what is concurrent queue. Queue means it is going to work in FIFO style, right? And if you want data in FIFO style, then you can go with the blocking collection. By default, it implement the concurrent queue, right? But if you want to implement the data, right? If you want to follow the LIFO principle, then you can go with concurrent stack. If you want, again, you can also do this concurrent bag. How? See how now, but see how it is possible. Now, the most important point that you need to keep in mind that you can pass any collection, right, to this blocking collection as a parameter, right? If that collection implement this I producer consumer pattern, right? Okay. I'm just giving you a idea, right? See, right? So in this case, I'm not passing any parameter to the blocking collection. In this case, I'm passing 100 as a parameter to the blocking collection. In this case, I'm passing this concurrent stack instance and the length as a parameter, right? So if you go to the definition, right, you can see one of the constructor doesn't take anything, right? And if you expand, so what is it is saying initializes a new instance of the blocking collection, right? Without an upper bound, means there is no capacity, right? In this case, you can see initialize a new instance of the concurrent collection class, right, with the specified upper bound. So in this case, you can, if you want, you can specify the what you can specify. You can specify the bound capacity, or if you do not want, you cannot specify, right? So in this case, I'm creating another collection. Right. So in this case, this is the one overloaded version. This is second overloaded version. This is third overloaded version. This is fourth overloaded version. Right now, you can see there are 4 overloaded version. Right. So this is fine. This 2 is fine. What I have shown you, these are the nothing but these 2 collection. Right. So in this case, I'm not specifying any type. What type you need to follow to store the data. By default, it is going to be generic queue. By default, it is going to be concurrent queue. Right now. Now, instead of a concurrent queue, you want to store the data by following the what data structure concurrent stack, or you want to store the data using concurrent bag. That you can also pass here. You can also pass concurrent stack. You can also pass concurrent bag, and by default, these 2 collection, it is going to store the data using concurrent queue. Right. So what kind of collection class object you can pass as a parameter, right? What kind of type, right? Type in the sense here you are passing one instance. What type of instance you can pass? Suppose you are getting confused. So let me simplify this. Okay, let me simplify this. So I can pass this as a parameter to here, right? Right. I can also pass a parameter to here, right? So you can see in this case, the first parameter I'm passing a concurrent stack collection, right? So I'm creating an instance of concurrent stack and I'm passing. So here I'm creating an instance of a concurrent bag and passing that collection, right? But if you go to the definition, in this case, let me go to the definition constructor of this class. It is saying that you need to pass a parameter which should implement this I producer consumer collection, right? So in this case, If I go to this blocking collection, right, then so not the blocking collection. If you go to the concurrent bag, if you go to the concurrent bag, you will see that it is implementing the iProducer consumer collection, right? So any type which implement this iProducer consumer collection, right, you can pass that type instance as a parameter to this constructor, right? And here, if you go to the concurrent stack, then you can see it is also implementing the iProducer consumer, right? And if you are not, it is also possible now you are explicitly telling that I want to store the data by following the stack data structure. I want to store the data by following the bag concurrent bag data structure. And if you are not telling anything, then by default it is going to be concurrent queue. Is that clear? And this parameter means this 100 means what is the limit, maximum how many elements at any given point of time your collection can hold that specified this number. Clear? Guys?
Yes, sir.
Right. So now how to add elements into the blocking collection, right? If you go to the definition of a blocking collection, you can see there is a add method, right? By using this add method, what is this cancellation token? I am not explained now. Once we start discussing asynchronous programming from tomorrow, we will discuss this cancellation token. So now we are going to use this add method to add elements, right? So you can see I'm using this add method to add elements, right? I'm creating a blocking collection. I'm specifying the size as 2. How many elements? What is the size I'm specifying here? 2. 2 means you can see these 2 elements will be added, but this element will not be added until and unless any of the element from this collection is consumed by any other thread, right? Clear or not? So here, why? Because this is the size you specified 2. And here adding 3 elements. 3 element means these 2 elements will be added because the size is 2. But this 3 element, the third element, while you are trying to add, will not be added until and unless any of the element from this collection is going to be consumed. If any of the element is consumed by any other thread, then as soon as any of the element consumed, this element will be added. Even though you can also use this triad method, right? This triad method is also going to do the same thing. This method is trying to add, right, the specified item to the collection. The parameter item specifies the item to be added to the collection. It returns true if item added, otherwise false, right? If the item is a duplicate and accept duplicate. See, in this case, suppose you are using one collection, right, which doesn't accept any duplicate element, right? And if you are trying to add a duplicate, you will get some kind of a exception. So basically, what kind of elements you can add and what type of operation you can perform, that basically depends on the type of a data structure you are using to store the element. You are using bag data structure, dictionary data structure, or you are using stack, queue, whatever data structure to store the element, that all the functionality or the principle that is applied to that data structure is also going to be applicable here, right? This triad method also having other overloaded version. In this case, if it is able to add the element, then it is going to return true. If not, so in this case, it is going to return false because you have specified the size as 2, right? Another option is that you can specify the times in milliseconds, right? Times in milliseconds means you can use time span, right? And you need to specify a Mr. Add method. Please wait 1 second to add this element. Within 1 second, if you are adding this element, then that is fine. If within 1 second you are unable to add this element, then just return false, right? So how to access the blocking collection? By using the for each loop, right? Let me show you one example. Right. So I'm not giving you the consumer pattern producer example yet. I will show you that. But before that, we just need to understand this concept. Add means adding element using add method. Triad method means I'm adding element using triad method. So I have specified the size as 4. Means these 2 elements will be added. These 2 elements will also be added because 4 elements. And when I'm using this triad method, it will wait for 1 second, and if within 1 second, right, any of the element that is available within this collection is consumed by any other thread, then it is going to add that element. But in this case, I'm not using that consumer thread, so it is a sequential thread. So in this case, you can see this, in this case, this else block is going to be executed, right? And accessing the element means using a for each loop, right? Right, you can see item 30 not added. Why item 30 not added? Because within 1 second it is unable to add the element. Why? Because the collection is already filled with 4 elements. You have set the maximum as 4, so it is unable to add the element, right? If any of the element in between, within this 1 second, if any of the element is removed from this collection, then it is going to add. Now what I'm trying to do is I'm going to remove this 4. Right now there is no size limitation. Now if you run the application, then you will see that item 30 is added, and that you can see in the collection. Clear? If you are specifying the size, then that you are specifying the bound, upper bound, that is the maximum number of elements that the collection can hold at any given point in time, right? And if you are not specifying, then there is no limitations, right? So it is also possible that if you look at this collection class, as this collection class having the add method, right? So as it is having the add method, then you can also use what? Collection initializer, right? Add method means you can implement the collection initializer, right? So you can see I'm using collection initializer, adding 4th element, right? If I'm trying to add a 5th element, it will block the blocking collection, right? So in this case, this element will not be added. So let me run the application. See, it is blocking the collection, right? Because it will not complete it, right? So now if I uncomment this one, right, then it is going to show me the elements, right? If you do not want to restrict the number of elements to be added, you just need to remove the, what you need to remove? This capacity, right? If you remove the capacity, then it is going to do the things, right? Okay. How to remove elements? Let me directly explain you this thing with example, right? So in this case, I'm creating a collection, and here I'm using the take method. Remove item using the take method, right? If you go to the definition, then what this take method is going, removes an item from the collection, right? And how the item is going to be removed, what item is going to be removed, that basically depends on the data structure. So queue means what? Queue means that FIFO principle, right? The element which is added first, that element is going to be removed by the collection. If you are implementing this using stack, then the element which is added last will be the one to be removed first, right? So basically, take method means it is going to remove the item, right? And what item it is removed, that will be stored here, right? Second one is a try take method. So try take method means what? Now it is trying to remove the item from the collection, right? And within this second, if it is able to remove the item, then that is fine, right? So for example, if the collection is empty, then in that case, there is no item in the collection, then it will wait for 1 second to so that if the other thread which is there, if they are adding the element within 1 second, then it will remove the element, and that element will be stored inside this variable, and it is going to return true. If within 1 second, right, there is no element to added, then in that case it is going to return false. And if there is any element, then that element is going to be simply removed, right? And here you can see, right, here if no more elements in the collection, I'm trying to remove using the add method, right? If there is no element, then this else flag is going to be execute. And in this case, you can not only specify the time using milliseconds, right, time span, you can also specify the time using the integer milliseconds, right? So here you can also write like 1000. 1000 means 1 second, right? If 1 second, if he is able to delete the item, then that is fine. So now, if you see how many elements are there in my collection, 2 elements. there is no size limitation, but I'm creating 2 elements, right? So in this case, in this case, 10 is the first element is added. So in this case, it is going to return me 10, right? And still this collection having a element. So in this case, in this result 2 variable, that element 20 will be stored, right? And in that case, this method is going to return true, and as it is returned true, this code is going to be executed. In this case, now the collection is empty. You have removed both the elements, so the collection is empty. And once the collection is empty, and if you are trying to remove the element, then it will wait this number of milliseconds, I mean 1 second. And within 1 second, if no more elements are added, then this method is going to store the default value 0, right? This variable is going to store the default value 0 because integer, it's a numeric type. And in this case, this method is going to return a false, and you will see this, right? Let me run the application. See, to show you what I'm saying, I'm giving this as 500, right? So you can see after 5 seconds, the next statement is going to be printed. See, no item removed by the try check method. And this is coming after 5 seconds. Is that clear? Guys? Hello? Guys? Yes or no?
Yes.
Okay. Right. Now, so before understanding the consumer and this consumer and producer design pattern, pattern, you need to understand something, right? You need to understand complete adding method, is adding completed, and is adding is completed properties, right? So if you go to this collection class, right, you will see that is completed, is adding completed, bounded capacity means the count, number of element bounded, what is the capacity, what is these 2 properties, that is what we need to understand. And there is also one complete adding method. These 3 things we need to understand, right? The producer thread call the complete adding method, right? So if you are going to implement a producer consumer pattern, right, then the producer thread need to call this complete adding method. This complete adding method internally mark the each adding complete property to true. The each completed property is used by the consumer thread, right? This is the method, right? This method is going to be called by the producer thread. And when you call this complete adding method, this method will internally mark this is adding completed property to true. What it means, now whenever suppose you want to add 1,000 elements to the collection, right? And once you add 1,000 elements, you need to call this complete adding method, which will indicate that the addition operation is done. The producer thread does its work. There is no more elements to be added. And how it will make sure? Now it will make sure by setting this is adding completed property to true. So you can say is adding completed. All these 4 properties, right? They are only having get accessor. Get accessor means what? Internally, you cannot set the property value, right? This property is value is internally set by this. I mean the framework, right? When you call this method means the addition operation is done. The producer thread saying that I have no more elements to add into the collection. So that's why I'm calling this complete addition method. And once the producer thread call this method, right, this is adding completed property, value will set to true, right? As long as you have not called this method, this value by default, it is going to be false. When you call this method, right, this property is going to be true. And when this property is going to be true, this is going to be, see, as a producer, you are calling this method. The producer thread internally, right, once you call this method internally setting this property value to true. Right now the consumer thread is going to use this property. So when this property is going to return true, now this is completed property is going to return true when this method is this property is adding completed is true and the collection is empty, right? To make you understand this thing, we need to understand something, right? So first we need to understand is adding completed, right? So is adding completed. This is a method. This method is going to be called by who is going to called by producer thread, right? So this method is going to be called by producer thread, and when this method called, what it will set? It will set is adding completed property to true.
True.
Right? So is complete adding method is called by the producer thread. Once he called, this property is going to be true, right? And this is the producer part, producer thread, right? So this is the producer thread, right? Then consumer thread, right? When the consumer thread consuming the element, right, he can check this property. He can check what is the value of this property. It might be your true or false. Then what is one it will check is the collection is empty. Is the collection is empty? Again, here it will get a true or false, right? So if you see, right? So you can see count property is there, which is going to return the number of elements. If the count property is 0, means what? Collection is empty or not? Guys?
Yes.
Right? So what it will check now, if each adding completed, if each adding completed equals to true and operation, collection is empty equals to true, then what he will do is completed, he will mark this is completed as true, right? If each adding completed is true but the collection is not empty, then he is going to consume the element, right? If each adding completed is false, and see, in this case this is true. Other scenario, let me show you the 3 different scenarios. Each adding completed is false, right? Collection is empty, then it is going to set this as false. Each adding completed is false, collection is empty, right? It is true, but the collection is not empty. Collection is not empty. Then in that case, it is marking this as false. When the each adding completed is true and the collection is empty, that means the operation is completed. So what it means, now you just tell me, if when this each adding completed will become true, when there is no more elements to add. Clear or not?
Yes, sir.
When the adding functionality is done, right, by the producer thread, he is calling this method. When he is calling this method, each adding completed property is set to true. Each adding completed true means what? There is no more elements to add. And if the collection is empty, that means what? All the elements are consumed by the consumer thread or not? If there is no more if there is no more element to be added, and if all the element from the collection is already consumed, that means the operation is completed or not?
Completed.
Yeah. And in this case, the each adding completed is false, and collect, even though the collection is empty, this property is false means what? It means there is a chance that the producer thread is going to add some element. So I cannot set this property as true. Coming to this way, each adding completed is true, right? There is no more elements to be added by the producer thread, but the collection is not empty yet. If the collection is not empty, that means I am going to consume some of the elements. Some of the element is still there, so I am going to consume those elements. So I cannot set this property to true. And in this case, there is no more element to be added. And the collection, I have already consumed all the elements from the collection. So the property I need to set it as true. So when this is completed property will return true when this is added completed is true and when the collection is empty. Clear? Guys?
Yes.
Right. So this is what now let me implement this thing with one example so that you will get how to implement that producer and consumer pattern, right? So in this case, you can see I'm having two threads. This is my producer item, right? So you can consider this needs to be executed by PRTU producer thread, right? And this method is going to be consumed by consumer thread, right? So I'm having two threads, two methods. One method is going to produce the item, right? So what my intention is, I'm going to add 10 elements to the collection, right? 10 elements to the collection. Here I'm simply creating a blocking collection of integer type. You can see I'm creating a blocking collection of integer type, and this is the shared collection. Shared collection. This collection is going to be shared by two threads. One thread is producer thread, another thread is consumer thread, right? Producer thread, what is the role of producer thread? To add the element. And here I'm using a for loop, right? And using this for loop, I'm adding the elements. How many elements? Currently, I'm adding 10 elements, but there is no limitation. You can add 10, 100,000 number of elements, right? And you can do different types of operations. Once you add all the elements, right? That means if your task is done, then which method you need to call? Guys, tell me which method you need to call.
Complete adding.
Complete adding method. So here you need to call the complete adding method. So once you call the complete adding method, so what it will do, it will mark that this collection is no more accept any element. There is no more addition. You cannot add any element to this collection when you call this method. So it will mark that this collection is not going to accept any more addition or any more element. And once you call this method, then it will internally say this is completed, is adding completed property to what value?
True.
True. Because the complete addition is done. Once you call this method, it will set this property to true. So this is my producer thread where is producing the element, right? Now my consumer thread is there, right? So this consumer thread will consume the element as long as, right? It will consume the element as long as this is completed property is false, right? When this is completed property will return true. When this property is going to return true means what? Means there is no more addition and there is no more element in the collection to be consumed, right? So as long as this property return me false, I can consume the element from the collection. Is that clear?
Yes.
Right. So in this case, I'm using while blocking collection dot is completed and I'm marking this as not. That means as long as this return me false, it will mark that as a true and it will execute the body. And once it return me what? Once it is return me true, true means when the collection is empty and is adding completed is done, right? In that case, it will return true and I'm using your not operator, right? So it will not execute the loop body. Right? And you know how to get the element by calling the take method. So you just need to call the take method and this take method will get the element from the collection. And once you get the element, whatever operation you want, you can. Right? So basically to give a better idea, what I'm trying to do is I'm writing console dot right line. Producer thread add element producer thread add element. What element the producer thread add? The producer thread add the I element, right? After adding the element, right, the producer thread sleep for some second. I'm making this to make you see the output clearly. Few milliseconds, right? And here I'm going to write the logic, right? Right? Consumer thread consume the item, right? Consumer thread consume the item. So in this case, let me run the application. You will see that both the operations are going to be performed parallelly. I am getting this error. Right. I am getting this error. Blocking collection is completed. Is completed means I equals to 0, I less than 10, I plus plus. While blocking collection that is completed, blocking collection dot take method, right, take method. Right. Now let me run the application. Complete adding. So dot right line. First thread add item is I dollar. Produces thread add item. Here consumer thread consume item. Right now. Plus 10 plus 10. 5 minutes. So you can see, guys, So producer thread adding 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Consumer thread consuming 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So why I'm getting this error, I could not understand. Suppose I'm making the thread to sleep for thread dot sleep for some second. I'm getting this error. The collection argument is empty and has been marked as complete with regard to addition. So why? Because see, the reason for this is that you cannot implement this manually. You cannot mark this thread to sleep for some second, because this is internally going to be managed by the framework, right? When the thread is going to be sleep and when the thread is going to be active, right? That is not in your hand, right? Because in this case, if the collection is empty, you cannot add more element, right? If the maximum, the limitation is reached, right? So in this case, you can see if I'm providing the maximum limitation as 5, right? So in this case, you can see so 0, 1, 2, 3, 4, 5 elements is added. Consumer thread consume 1 element, right? So similarly, the other element is going to be added, right? So basically what it means you cannot mark or you cannot call that thread sleep method manually. So in this case, you can see parallelly, right? Parallelly, the elements are going to be added and parallelly, the elements are going to be consumed by the thread. So you can see some of the elements added, then some of the elements are consumed, right? Then few elements are added, then all elements are going to consume, right? But once it reaches the maximum limitation, then it is going to wait for some of the elements to be consumed. See, in this case, we have set the maximum sizes 5, 0, 1, 2, 3, 4, 5, right? Some of the elements are added. Then some of the elements are going to be consumed by the consumer thread, right? Each time you run the application, you will get a different output. Then you might be having some issue here, sir, how it possible that 6 elements are added then consumed? It is not like that. So we are getting the output in this sequence, right? So from this output, once the element, so in this case, you can see once the element is taken, right? Then in that case, okay, to give you a better idea, so it will take some time. So I'm directly calling this method here, right? So in this case, you will see that maximum 5 elements are going to be added. See, 0, 1, 2, 3, 4, 5, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, each time you run the application, you will get a different output, right? So every time you run the application, you will get a different output. So what will happen? Now, some of the elements are going to be added, right? And while some of the elements, so in this case, why you are not getting the output? Because as soon as you consume this element, right? So you call this method will remove the element. Immediately the element other thread is going to be added. Then that return element, what it is displaying, it will be displayed afterwards, right? So this is the reason why you can see the sequence is not going to be accurate, but behind the scene, see, in this statement, what is exactly happening? Now, first of all, it is making a call to this take method, right? So when it is calling this take method internally remove one item, right? As it internally remove one item, immediately the other thread which is there in the sequence is adding one item, and after calling this method, what value it is returning, it is printing that value here, right? So in this case, this is the reason why you can see some of the time this sixth element is already added, but you can see this element is added here. You can see the output immediately, because in this case, right, after adding the fifth element, the consumer thread calling the take method, once it call the take method, one of the element is removed from the collection and immediately this is written. And after then, when this method return, right, when this method return, that return what printing statement I have written, that is going to be displayed. So you cannot simply predict the output, right? But in this case, your addition and your consumption is going to be happen parallel. Is that clear, guys? Hello? Hello.
Yes, yes, it is.
Right. So basically, you cannot. So don't think that how it is showing me. See, in this case now you can see 0, 1, 2, 3, 4, 5 elements are there. Then it is consuming. So the sequence which is getting more frequent time, you cannot simply predict, right? Which thread when it is going to execute, right? As we already discussed from the beginning, right? If you are using multi-threading, right, then the sequence of the output you cannot predict. Every time you run the application, you will get a different sequence of output, right? This is the reason why now you can see currently 5 threads are added, then consuming 3, 1, 2, 3, 4, then adding rest 5 elements, then consuming the rest 6 elements, right? So simply the output you cannot predict, but what you can predict, both the operations are happening simultaneously. This thread is producing the item and this thread is consuming the item, right? Suppose you are implementing one messaging application, right? So messaging application means you want to send a message to your friend, right? So your message server is there. So whenever you are sending that message will be so you are the producer. In that case, your message will be stored inside this collection, right? And from this collection, you want to take the message and you want to forward that message to your friend. That is nothing but to roll up this consumer, right? From your mobile phone, you are sending the message, means you are just calling this produce item method, and that item will be stored inside the messaging queue, and from the queue, right, it is picking one of the item and it will forward that message to the appropriate receiver, right? So this messaging pattern, right, you can see is implemented by following this producer and consumer pattern, right? Producer is going to produce the element and consumer is going to consume the element. Both are having two different threads. You can see this is my producer thread, which is calling the produce item method, consumer thread calling the consume item method. And you know what is the use of this join method. Clear?
Yes.
Guys, that's it for today. Anybody having any question? Any question?
No questions.
Okay, fine. Anyone else? Okay. So from tomorrow, I'm going to start asynchronous programming, which is very, very important, right? Please try to attend the classes. Otherwise, it is going to be your loss, right? See, everything is not available in the document, right? Whatever I'm showing, whatever modification I'm doing in the example, right? These things are not available in the document, right? So you have to attend the sessions. Why I'm saying? Because actually, you know why I'm taking one day leave. Why I'm not attending the sessions regularly, because of the documentation part, right? Taking more time on the documentation, right? So what I'm planning, I'm going to cover the concept as much as possible, as soon as possible, and I'm going to explain those things practically here instead of writing the documentation. Documentation, what is required, I will provide, but most of the things I'm going to explain in the classroom only. Because I don't want to waste daily 3 hours for preparing the documentation, right? So it is mandatory, and you should attend the classes regularly. Otherwise, I know people will not watch the videos continuously for 2.5 hours because they do not have that much of time so that they can watch the complete video, right? They are preparing the document what I'm sharing. But going further, the documentation is not going to contain all the things, because I'm not going to spend a daily 3 hours for preparing the documentation. Instead, I will spend that time to explain the concept to you, right? So from the beginning, I have told you I will explain this thing later. So now you can see at the end, the producer thread will call the complete add method of the blocking collection class. The complete adding method set the is completed property to true. The consumer thread internally not is completed. It will call what that property is adding completed. Right, is adding completed to true. The consumer thread internally monitors the is completed property to whether there are any items to consume from the collection. If this is not clear, we'll try to understand and we have explained these things. And this is the reason why from the beginning I have not explained this thing, because if I explain this thing from the beginning, you will be getting some query, right? This is the reason why I moved this to later part. That's it for today. Thank you for giving your time. Hope from tomorrow onwards you guys are going to attend, because see, if out of 30 students, if 10 12 students are attending the session, right, then it is not a good thing. Out of 30 students, 5-7 students having some issue, that is manageable, but at least more than 20 students should be available, right? And as I mentioned, going further, I'm going to explain everything in the classroom. Documentation will not cover everything. Example code is available in the documentation. I will provide you the examples, right? But you have to attend the session. You can do the example by yourself. I will share the code, but the explanation, right? What is this bounding? What is this blocking, right? This thing, what is this collection class, right? As I'm mentioning, how to create the step, everything, right? Note point, everything is not going to be there. Yes, what is there? This example will be there, right? This example, what I'm showing, this thing I'm going to provide, right? So you have to attend the sessions, because if I'm writing these things manually, right, it is a very difficult task to prepare the documentation. And if you think that preparing this documentation is not a difficult task, just try yourself. Watch the video, prepare the document by yourself, then you will know how difficult it is to prepare the documentation. Right? Thank you everyone. Please try to attend. Otherwise, see why I'm saying this, because people are not attending because of this documentation. But if they are not attending, they are losing many things. I don't want anyone to lose anything. If everyone will attend the class, then no matter how much time it will be, how difficult for me to prepare the document, I will prepare the document. If you guys are not attending the session, then I will not prepare the documentation. I will only explain the concept. Right. Thank you guys.